Hello there and welcome to Lower 6 Further Maths A-Level. This is the January mock exam revision sheet 4, here on a series question. So, write out the series defined by this expression here and find its value. Okay, I think here what they're looking for you to do is, this is the summation, plugging in the numbers from 7 up to 12. So what we'll do is, using the numbers 7, 8, 9, 10, 11 and 12, we're going to plug these values into this expression here and add all of those results together. So let's might be an idea to expand this. So 3r squared. So we're going to get here 7 times 49 times by 3, and we're going to get 7 times by 3 is 147. Add on 14 and we are going to get 161. Plugging in the next value 8, we're going to get 208. Plugging in the next value we get 261. Then it's 320 for when we plug in the value of 10 into this formula here. And then the 11 is going to give us 385. The next one's going to give us a 456. And we get an answer there of 1791. Okay, so that's what they're looking for you to do in that question. When the numbers are low and you can plug them into the formula, I would go ahead and do that. Okay, so we can always check this value here by using the series button on our calculator, shift and the X button, and then plug in your starting point and your end point. You can't use R, you have to use this button X, so it looks a little bit different from it, but it's exactly the same, and you get 1791. Okay, show that the summation from n plus 1 up to 2n is equal to this expression here. Now at the moment I haven't even got an expression for this series from 1 up to n, so I think I'll work that out first. So the series will expand this as well, so we'll get 2r plus 3r squared, and the way we'll find out a formula to work out the summation from 1 up to n is by splitting this apart and adding the separate components together. We're going to bring in some formulas as well to help us out. So the formula for the sum of r squared is n over 2 n plus 1, and the formula for the sum of the r squared terms is n over 6 n plus 1 2n plus 1. Okay, and now we're going to simplify these together, so we're going to get 2n over 2, I'll show you why I'm keeping that like that in a second, plus 3 over 6, that's the same as n over 2. You can see there now I've got the same denominators, so when I try and factorise in my next steps, it's going to be a lot easier to pull out that denominator of 2. So here is the factorising step. I'm going to try and pull out as many common terms between the left hand and the right hand term. In both of them I've got an n, in both of them I've got a half, in both of them I've got an n plus 1, and that's all I've got in common between both of them. In the left hand side what I've got left is just the 2, and in the right hand side all that I've got left is the 2n plus 1. So this right hand side bracket here must be 2n plus 3. So the formula for the summation of 1 up to n is n over 2 n plus 1 2n plus 3. Okay, so now we can get to work on this question here. What we're going to do with this value here is split apart the summation from n plus 1 of our function into the summation up to the value 2n. So we're going to add together more terms than we need effectively here. If I'm adding together, let's just do a basic example, the numbers 1 up to I'm adding up, say, the numbers from 4 up to 6, then using a formula that works out all of the summations of my numbers, I could potentially work out the summation up from 1 up to 6, and then take away this 1 up to 3 to leave me with 4, 5, and 6. So that's what I'm going to do here. So I'm going to need to take away the summation of my function from 1. Now if I'm adding up the numbers from 4 up to 6, then I would take away the numbers from 3 downwards. So if I'm adding up the numbers from n plus 1, I'm going to take away the numbers from n downwards, because I want to include that n plus 1 still in my summation. So what I'm going to do now is bringing this formula here back in, substituting in 2n for the first expression and n for the second expression. So in the first expression here, it's going to be 2n over 2, 2n plus 1, so you substitute in the 2n at every possible n that you see, and then it's 4n plus 3. And in the second term here, it's just exactly what it was before, because you're just substituting in an n. Okay, so let's go ahead and expand some of these brackets. I think I'll leave the n's at the front. In fact, I could factorise now, couldn't I? Let's pull out the n and the factor of 2. That's all we have in common between both of them. So we're going to leave the 2n plus 1 and the 4n plus 3 inside that bracket. I'm going to take away the n plus 1 and the 2n plus 3. Now be really careful here with your double negatives and make sure you take away everything from that last term. So we're going to get n over 2 bracket. Okay, expanding this all in one go. Let's give it a go. 8n squared, so that'll be 16n squared. Then we're going to get 6n plus another 4n, that's 10n. So that's going to be in total 20n. And 3 times by 2 is 6. Okay, we're going to take away everything from the right hand bracket, so that's going to be 2n squared. Take away 2n, add another 3n, let's take away 5n, and we need to take away the 6 as well. No, not 6, where did that come from? Take away 3. So, fingers crossed, it's going to match up with what we've got here, and if it doesn't, we'll go through and see if we've made a tiny little mistake somewhere. So, 14n squared, add 15n, add 3. Yeah, good, that's what we've got. Phew! Alright then, that's 7 marks for that question then. So yeah, there's a few key points here. So we're using formulas to split up summations and combine them into one formula. And the second part here was to split up a summation that doesn't start at 1. You have to do the one summation up until the top value, and then you subtract the summation up to 1 less than your bottom value there, because if you're adding up, say, the numbers from 4 to 6, then you need to take away the values from 3 downwards. Alright, that's 9 marks for that question.